The first thing we'll need is a new repo, so we'll initialize one. A lot of stuff is going on here, but essentially we're setting up the database for the project. Now let's copy our files into the working folder and add them to the index. The Git index is a holding area where we build the contents of our commit before actually committing it. Git doesn't really care about the contents of your files. All files are just considered a data blob. When we add it to the index, the file's contents are hashed, and it's stored in the database under that value. Git represents the hash as a 40-character string. Here we're going to use their card values, so the foo file hashes to the jack of diamonds. We'll put it over here for the moment and move on. Now we'll take the bar blob, hash it to the 5 of clubs, and set it aside. Baz will be treated in the same way, hashing to the 7 of clubs. Right now, we've got data ready to go into a repo, but nothing to indicate how it all fits together, so we're going to need to create a tree object. To do this, we're going to record 3 pieces of information for each object: the object's name, its hash, and what type of object it is. We'll create a new text file with this information, hash it based on its content, and store it in the database as well. Moving up the line, we'll build the next level of the tree. It references the tree and blob below it. Hash it, and drop it into the index. I'd like to point out a couple of things at this point. Notice that each object in the tree is hashed based on its content, whether it is a blob or a tree object. As previously stated, a SHA-1 hash will change if a single bit is altered anywhere in the file. The practical upshot of this is that if any bit in any of the files change, or if a file is renamed, those changes will cascade up because each level contains a reference in its text to the next level down. Because the hashes are statistically unique, we can look at any node, and if its hash is unchanged, we can be certain that not only its contents are unchanged, but also all of its children are unchanged. We'll be working exclusively in the settings folder, so while in a real Git repo, all of the contents of the app folder would be added just like in the settings folder. For our purposes, the only thing we need to know about the app folder is that its hash is the 2 of diamonds. It could contain 3 files or 3 million, and because it remains unchanged, we're safe for everything we'll be doing. This is one of the features that makes comparing trees in Git so incredibly fast. We're up to the root, so we'll create the top level of the tree and get ready to commit our code. Now that our data is stored in the index and our tree is ready, we're ready to make our commit, which means that we'll need to put a few pieces of information into our commit file. First, we need a commit message, in this case, initial commit. Second, we need the author of the commit. We'll reference them by their name and their email address. In a real repo, we'd store the date and time of the commit as well, and you have the option of specifying both an author and a committer, but we'll simplify here. Third, we need to reference the tree object that represents our index. And finally, the commit's parents. The first commit of the repo will be the only one without parents. This file too will be hashed and stored in the database. We're almost done, but right now there's nothing to tell us which of the objects in the database is our commit, or which commit is current when there are more than one. To solve this problem, we'll create a branch. Our default branch is called master. A branch is just a special file in the database which contains only the 40-character hash of the commit at the head of the branch. Use a post-it note to mark the head of the branch on a branch card. Now that we've officially got data in our repo, it's time to leverage the version part of version control system, so we're going to need to make some changes. Let's make a change in the file Baz. As we've already discussed, Git always stores files as complete blobs, and it doesn't really care about their contents until it needs to compare it to something else. So let's add it to the index, which will hash the file as the 5 of diamonds. Because the hash of the file is changed, all of the tree objects that reference it are now invalid, so they will need to be updated and recalculated. We'll work our way up the tree to the root, and update the contents of the index as well. Finally, once we've crafted our commit in the index, we're ready to commit. The only real difference here is that now our commit is going to be made on the master branch, so the current head of the branch, the Queen of Hearts, will be referenced as the parent of this commit. These parent references are what allow Git to track the history of a commit, and by extension, a branch. And finally, we need to update our branch to point to the new commit. Because of this simple referencing system, we can start from the head of our branch, and by reading its parent and its parent's parent and so on, we can very quickly reconstruct the history of a branch. Reconstruction of a branch is so fast and easy that Git doesn't even need to store explicit branch information. The one 40-character hash reference in the branch file is all it takes. This is what people are talking about when they say that branching in Git is very cheap. Creating a branch only adds 41 bytes to your total repo size. So far, only one person is working on a single instance of the repo, but Git is a distributed system that really shines for teams. So let's move over to one of Deril's teammates' computers for a moment. If you're playing at home, you'll be playing Kaylee for the time being. At the moment, you don't have anything in your repo, so you'll need to get a copy of the repo so you can start work. To do this, you'll clone the repo from another member of the team, in this case, Deril. Pull out these cards and add them to Kaylee's deck in your hands. When Kaylee clones the repo, the source repo is going to pull all of the active objects in its deck and package them. To accomplish this, it's going to start at the head of each branch and build out the tree, building a manifest of objects as it goes. Then it will work its way backwards through the history until it reaches the initial commit. Once the manifest is built, it will package it up and send it to Kaylee. Kaylee will then add all of those objects to her deck. The repo will also send references like branches and tags. Branches will be specified as belonging to the original repo, by default, origin. Kaylee will need a safe place to work, so a local master branch is created, and a marker is added internally so Git knows to relate it to the master branch of its origin. Kaylee is free to start working, but for the moment, let's move back to Deril's repo and do a little more work.